This is Ms. Hirschville. I have people asking questions about electron emission of light. So I thought I would try to record a very short video quickly while my daughter was at ballet. So sorry for me scribbling on someone's paper to try to explain this to you. We've talked before about how electrons fill up different energy levels. So we have the 1s level, and we have the 2s level, and we have the 2p level. And I'm just going to draw those three really quickly for right now. Hydrogen has one electron. That one electron wants to stay in the 1s energy level. We call that the ground state. That is the normal state for that particular electron. But sometimes an atom can absorb energy. So maybe it gets heated, or maybe a big chunk of electricity is thrown into it, or it gets hit by a really strong light, something like that. And when that happens, that energy can grab that electron and push it up into a higher level. So now that electron is sitting right here at the 2s level. That's what we call the excited state. Anything above where it normally is called the excited state. The electron can't stay there for very long. So after a while, the electron travels from the excited state back down to the ground state. Well, in physics, you guys learned that when something was up higher, it gained potential energy. And the same thing happened to our electron. When the thing goes down lower, that potential energy changes to something else. In physics, it changed into kinetic energy. In this particular case, that energy changes into light energy in the form of a particle of light called a photon. Every time an electron goes from one energy state to another, it loses a very specific amount of energy. And so it releases a photon at a specific frequency. And when we're talking about light, frequency equals color. So when this one electron from hydrogen jumps up to the 2s state and then back down to the 1s state, it gains some energy to go up to the 2s, and then it had to give away that energy when it jumped down. It gave away that energy in the form of a photon, which has a specific frequency and thus color, because it lost a very specific amount of energy. I'm going to explain it to you like this. Here's the ground in my classroom, and this is me standing on the ground. Well, next to me, there's a chair. I can choose to stand in the chair, and I gained a certain amount of potential energy. When I gained that potential energy, I'm going to make up a number here, okay? Let's say I gained 10 newtons of potential energy. Well, when I jumped down from the chair, I lost those 10 newtons of energy. I emitted or gave off those 10 newtons of energy. Now, I can't stand halfway between the floor and the chair. I can stand on the floor or on the chair. So I can have 0 newtons of potential energy, or I can have 10 newtons of potential energy. But I can't have anything in between. I can't hover in the air in between the ground and the chair. So when I give off energy, I can give off 10 newtons, but that's all. That's all I have to give. I can't give off less than 10 newtons because then I would be hovering in midair, and I can't give off more than 10 newtons because that's all I have. Well, I also have tables in my room, and this particular one is very tall. And if I stand on top of this table, now I'm going to have 25 newtons of energy. I could choose to jump off the table. And if I did that, then I would give off 25 newtons of energy. Or I could choose to jump from the table onto the chair. And if I did that, I would go from 25 newtons of energy to 10 newtons of energy, and that means that I gave off 15 newtons. So one person can give off 10 newtons of energy, or 25 newtons of energy, or 15 newtons of energy. So one person has 3 possible outcomes when they give off energy. Let's bring this back to our electron. our electron could go up to 2s and back down and give off a certain amount of energy in the form of a photon. But that electron could also jump all the way up here to the 2p energy level. From 2p, it could jump down to 2s and give off a certain amount of energy, or it could jump all the way down to 1s and give off another amount of energy. That's just like me being on this table, and I can either jump all the way down to the floor or I can jump down onto the chair. So I have 3 different possibilities of the amount of energy that I can give off when I jump off of the table or if I jump off of the chair. This electron has several different possible choices of energy, or several different amounts of energy that it can give off. Each time the electron jumps from a higher level to a lower level, it gives off a photon. But depending on which levels it jumps from, it gives off different frequencies of light. It gives off different photons. So perhaps, and I'm just making this up because I don't have any reference tables with me, perhaps if it jumps from 2p to 1s, it gives off a red photon. If it jumps off from 2p to 2s, it gives off a green photon. If it jumps from 2s to 1s, it gives off a yellow photon. Again, I have absolutely just made these up. Please don't count on those being the specific colors. When this happens, the atoms give off certain frequencies of light. So you might see something called a bright line spectrum. And in this particular case, hydrogen has 3 different colors that it can give off. So here is our spectrum, and that's sort of a continuous rainbow of colors. We would go from red here to orange to yellow to green to blue to indigo to violet. Well, the electron can't be halfway in between the p and the s. It can't be halfway in between the 2s and the 1s. Just like I can't be halfway in between the chair and the floor. I have to be on the floor or on the chair. The electron has to be at the 2p or the 2s or the 1s. It can't be in between any of those. So it can only give off these very specific photons. So instead of a continuous spectrum of light, what we're going to see is one bright line in red, and one bright line in green, and one bright line in yellow. And we wouldn't see any other lines. And so we would say, oh, everything that has this red and this yellow and this green, that must be hydrogen, because only hydrogen has those. Every element has a distinct set of lines on the bright line spectrum, and we can use those like finger